Okay, so guys, welcome back to Smart Tech once more. Today we're gonna be talking about how you can use your 12 volts immersion heater. How you can use your 12 volts immersion heater. So on 24 volts battery or 24 volts system. So if you look at this, my battery, these are two batteries. These are two batteries, and it's already reading. This is the charge controller. So I ordered this from AliExpress. I ordered it up to 20 pieces, and I didn't know that I thought they are gonna mix it. They're gonna mix it together like 12 and 24, but they just gave me only 12, and my voltage system is 24 volts. And I just found out that when I put this 12 volts on normal 12 volts, the heater will stay like almost, if I want to boil a quantity of water, or if I want to heat up a quantity of water as big as this, I know this boiler or this immersion heater is made for teacup. But even at that teacup size of water, it still does not boil anything. So I found out that if you do this, if you plug this in 24 volts, it will work better. So there are two ways of doing it. It's either you use a step down, or you connect this three of this or two of this in series. But I've tried connecting to step down booster. Using step down booster, it did not give me what I was looking for. Though it worked, but it didn't give me what I was looking for. But when I now combined these two like this in series, I actually got what I was looking for. For a 10 liter bucket like this, it heats up the water for me to take bath during the cold weather at like within 10 to 15 minutes. I'm not actually heating it up to boil. I just needed it to be hot enough for me to take my bath. So let's get our whiteboard. So see what I'm trying to explain. If you have a heater like this, so, and you have another heater, I'm just giving an example. So if there are two, this is plus, this is minus. This is plus, this is minus. So you can just connect this in series. When you connect this thing, these two in series, you will now plug the negative part here to the negative of your battery. And so what will now be going here is 24 volts. 24 volts. But initially these two, they were 12 volts each. So what is happening? What happens is that there is what we call impedance. So this is the internal resistance of a given material. So impedance. So is an internal resistance of a given material. So what happens is that when you combine two of the immersion heater together, is going to increase the impedance. And once the impedance increases, it's going to help to step down or suck up the voltage potential that is going to take in, thereby increasing the heating effect and thereby not breaking down easily. So I tried to, it gave me what I was looking for, but I want to see if 3 can work much more effectively. So let's connect and see, guys. So guys, as you can see, I'm already cutting it. So you need to cut it. Remember to check the polarity while cutting. So guys, if you look here, you can decide to use a binding wire to bind your own. You can also use super glue or gum to take it together. But me, I prefer binding wire because gum at some point will just be free and loose. This one can also loose, but you can tighten it anytime you want. So guys, we're gonna try what we have already said. So if you look at this, the the end terminal is connected to another end terminal of this one, and just like that. So it's connected in series, as I told you. So guys, you see the total impedance is given at 4.4. Let me see if the total impedance is given at 4.2. So as I've told you, that means the total, that is when I add up the three heaters, is giving 4.2. But at an individual impedance, we are having a 1.2, and this is very, very catastrophic for a 24-volt system, because it's going to just burst this thing. As I was saying, this is the, let's say this is the second heater, and this is also the third heater. So I can, so that we will now have 24 here. So if you look at it, 1.2, 1.2, 1.2, which later gave us a 4.2 impedance, or 4.2 ohms. So the total impedance is giving us 4.2. So let's calculate. I have, my battery is actually 150 amps. Then it is 24 volts. So normally if you multiply it, it should be giving you, this multiplied by this will give us 3600 watts. So you are supposed to use a very strong alligator terminal. So this is a good one, so that you know it draws a very high current, around 15 to 20 or 30 amps. So that's it. Then if you don't have a very big thick wire like this one or this one, very thick wire, you can get other like 1.5 mm into 4 and join them together to create the thickness you are looking for, so they can be able to withhold the current or carry the current. So guys, I've connected it and I've put it in water. So I'm gonna update you guys how many minutes it took to start coming up to a degree of like 70 degrees Celsius.